Okay, we are starting chapter 15 here, summation of series. I hope you remember what does this mean. Essentially, it just means substitute r equals to 1 um, into this general expression. Then followed by a next integer, r equals to 2 here. Then r equals to 3, r equals to 4, r equals to 5 into this general expression. And the final r is here. Right? That's simple enough. So actually, there's no difference if you replace it with a star. No difference at all. So can we just safely say that in general, if I write the summation sign r equals to 1 to n ur must be equal to u1 plus u2 plus u3 all the way to un. Now if I don't start from r equals to 1, I can start with r equals to n to n. Doesn't matter, n can be any value as long as my n is larger than m. So I have un plus 1 all the way to un for November. Quite easy. How many terms do you expect in this sum? I give you a quick example. R equal to 5 to 10 ur. How many terms are there? It's 5, 6, 7, 8, 9, 10. There should be 6 terms, not 5. So therefore, in general, it should be n minus n plus 1. Alright, let's look at example 1, which shouldn't be too difficult. I sub r equals to 20 in, I get 20. Next integer, 21, 22, all the way. And because it is summed to infinity, the last term is infinity, it's just ends here like that. What about this? It's important to add this bracket here, otherwise the meaning is totally different. It will be sub k equals to 1 here, I get 2 plus sub k equals 1 into r square, I should still get r square, plus 4, because I sub k equals to 2 in, plus r square, and on and on. 6 plus r square, last term should be 2n plus r square. Quite easy. The interesting bit about this example 3 is if I sub r equals to 1, okay, minus 1 cube. Correct? Because minus 1 to the power of 1 is minus. If I sub minus, I sub r equals to 2 into this. R equals to 2 into this, I get minus 1 square, which is actually 1. So actually I get plus 2 cube. Alright? And next, minus 1 to the power of 3, I will get minus. You realize that the sign alternates all the way to the last term, minus 1 to the power of n. We do not know whether n is odd or even, so we leave it as that. Now, what is the objective of example 1 part 4 is to cast this into a summation sign. So what is the general expression for this? It's not difficult to see that it's 2r minus 1. Because I sub r equals to 1, I get 1. R equals to 2, I get 3. And 5, 7, etc. Now interesting, you should note what is the last term here? the last term here should be, because there are n terms, it should be. Now, it's not difficult to note that there are more than one answers. Can it be 2r plus 1? I think we can. It's r equals to 0, and it's the same. Alright? Don't believe you try. Okay. The next part about the whole chapter is we recall in APGP, we wanted to find a formula in terms of n, or the sum of n terms. Can we do the same for a general series? We'll look at it in the next part.